When the long night of the universe falls, it is the most intense, slightly diffuse. There is a black sun, where the light of all the stars has been extinguished. Rise quietly. He has not burned himself to illuminate the darkness. It's darkness that defines light. This is the largest known black hole, Ton 618. The existence of an ultimate celestial body that redefines the universe. He ends with the mass of 66 billion sun. On the scroll of time and space, write the next metaphor for eternal darkness. He is silent, but he devours the silence of all things, telling the deepest philosophies of the universe. Today, so we're going to push the boundaries of physics, shaking the giants of the theory of the formation of the universe, the mystery of Ton 618. It started back in 1957 at the Tonin Shintra Observatory in Mexico. In a routine night sky observation, noticed an inconspicuous blue blip. Initially, he is thought to be just an ordinary blue hang. The star was given the designation Ton 618. This name, it is also derived from the observatory where he was found. He maintained this identity for nearly a decade. However, in the late 1960s, with the advance of observation technology and deeper research, a surprising fact has emerged. Ton 18 is by no means a simple star. It located at the junction of Canis Retriever and Comer. It is a distance from us, 10.40 billion light years away. Despite the vastness of space and time, the light he bursts out is equivalent to the sum of 140 trillion suns. Scientists have realized that they discovered a quasar, the brightest class of celestial bodies in the universe. In its core area is a true cosmic giant, a supermassive black on an unprecedented scale. Whole, its mass is estimated to be 66 billion times that of the Sun. And how does that work? We can make a comparison. Our Sun, enough to hold more than 1 million Earths. Is it big enough? But if the Sun is placed next to Ton 618, the Sun is like Mount Everest, a grain of sand under your feet. The radius of the event world of this supermassive black hole, more than 1,300 astronomical units. Imagine that. If body temperature 618 is placed at the center of the solar system, then his event world will go far beyond Neptune, even the orbit of Pluto. Even if you reach the outermost planet in the solar system, and only from the center of this black hole, less than 5% of the way to the edge of its world. Even light takes weeks to cross from one end to the other. Certainly, what we observe is not the black hole itself. What we see, it was driven by him, that incredibly bright quasar. When the surrounding universe, gas and dust matter in space, under the attractive force of the Ton 618, in a spiral trajectory, falling into this bottomless pit of attractive force, they will form a huge and blazing disc-like structure. This is the suction plate. In this suction tray, matter is compressed by extremely attractive forces and intense friction. Temperatures skyrocketed to millions of degrees Celsius. It releases the overlay, intense radiation across the entire electromagnetic spectrum. The energy released by this process, beyond our imagination. Make TON, the light emitted by the inner star driven by 618. It could even cover the entire galaxy he's in. In the known universe, one of the brightest continuously luminous celestial bodies. Although supernova explosions may unfold in a short period of time, show more dazzling, but it will quickly fade after a few weeks. And Timothy 618, the cosmic beacon, it is speculated that it may have been. It burned continuously for millions of years. But here's the thing, the course of his journey remains a mystery to this day. The TON we observe today, the light emitted by 618, he actually sent it 10.40 billion years ago. This means that the universe was about 3.40 billion years old on a cosmological scale. When the universe was young, the problem is this: how exactly did a black hole survive in the early universe? It has grown to such an amazing size. The traditional theory of black hole growth holds that black hole, from the collapse of a massive star with attractive force, and then by devouring the surrounding material and mergers with other black holes to gradually increase the quality. But such a theoretical model, it seems difficult to achieve in such a short cosmic time, symbolizes such a huge black hole. Scientists have also come up with some explanations for this. One of the widely discussed theories is body temperature 618. It could be a so-called direct collapse black hole. This theory holds that in the early universe, some primitive strange clouds of enormous mass, maybe under its own attractive force, direct collapse, forming a supermassive black hole seed. Skipping the stage of stellar evolution, it laid the foundation for its rapid growth. Another possibility is Ton 618 experienced multiple black hole transmissions, fast continuous merge events, mass builds up quickly. There's also theory TO in 618 may be far more than our current models predict. Super Eddington hormone absorption rate in a frenzy of devouring matter. Its myopia efficiency is much higher than that of ordinary black holes. Well, in theory, there appears to be an upper limit to the growth of black holes, Eddington limit. And the simple answer is this: as matter accelerates towards the black hole, it will be heated and emit intense radiation. The outward pressure generated by this radiation will resist further falling of subsequent substances to the speed at which the black hole swallows matter. It's a kind of self-regulating constraint. According to this Eddington limit, and estimate the age of the universe, theoretical model prediction, theoretical maximum mass of a black hole, about 50 billion times the mass of the sun. However, the sticker temperature 618, with its high 66 billion times the mass of the sun, breaking through this theoretically predicted value. This undoubtedly implies that our understanding of how black holes grow may be not complete enough, or the travel process of TO in 618 has indeed experienced some special way to explain extreme celestial bodies like Ton 618. Some theoretical physicists have proposed more audacious originators say. For example, they could be after and early in the Big Bang. From the density of the original universe, a directly formed primordial black hole, or by large clumps of dark matter, collapsed by direct attractive force under certain conditions. Of course, these theories still exist in the speculative and exploratory stage, lack of direct observational evidence. But it is a universe like Ton 618. Existence of heterogeneity. It challenges our existing theoretical framework. The framework prompts scientists to explore, expanding the boundaries of cosmic cognition, explore deeper physical laws. Then in the universe, can you compete with TO and 618? And the answer is yes. For example, S5001 for 811. The mass distance of the central black hole estimated to be approximately 40 billion times the mass of the sun. But there is a view that, due to this quasi-star, relativistic jet of body points exactly in the direction of the Earth, makes its observed brightness. The degree may have been artificially magnified. Therefore, there is some uncertainty in the quality estimation. The other is located in IC, the supermassive black hole at the center of Galaxy 1101. IC 1101. It is already one of the largest galaxies in the known universe. The mass of the central black hole is about 40 billion, between 100 billion times the mass of the sun. But he's too far away, and shrouded in the light of the galaxy itself. Perform accurate quality measurements on it, facing tremendous technical challenges. Are you also curious? How is this mass calculated? Basically, there are two ways. One is to observe the motion of celestial bodies around black holes. The core principle is attractive force. The more massive the black hole is, the more attractive force surrounding celestial bodies, like stars and gas clouds orbiting faster. Scientists look through telescopes, analyze the Doppler effect of the light from these celestial bodies, a red or blue meter of light wavelength, to accurately calculate their visual speed. Knowing the speed and track size, according to the law of gravity, the mass of the central black hole. For example, Sagittarius is measured like this. The second is for types like 2 and 618. A little more complicated. Need to analyze its suction plate and wide emission line area. These kinds of black holes have bright suction disks around them and high-speed gas clouds. That's the broad emission line region. Through spectral analysis, measurement of the spectrum emitted by the gas with a wide emission line widening degree. The wider it is, the faster the average velocity of the gas. And then there's reverberation mapping. The central source of the quasar changes in brightness. This change will be a little later. Affects the brightness of the wide emission line curved gas. Generate light bounce. Measure this time delay. Can be estimated later. The distance from the wide emission line region to the central black hole, with the speed and distance of the gas cloud. Also according to the law of gravity. Calculate the mass of the central black hole. Study extreme celestial bodies like Ton 618, not just to satisfy curiosity. It's about understanding. An important part of the formation and evolution of galaxies, there is growing evidence that supermassive black hole and its host galaxy, there's a co-evolutionary relationship. For example, the mass of the black hole at the center of the galaxy, the mass of the ball that often merges with its host and the galactic constant. The random motion speed of stars is closely related to other characteristics. Nowadays, with people like advanced equipment like space telescopes put into use, astronomers can go deeper. Study distant quasars like Ton 618. At the same time, rapid development of attractive force wave astronomy, it also provides us with a whole new observation window. Scientists expect future attractive force wave observatory. It may be possible to directly detect, similar to Ton 618 black hole of this size, the ripples in space and time created when the merger occurs. The most massive in the known universe. Massive black hole. It was significant for his research. In this universe full of wonders and unknowns, the existence of TO in 618 always reminds us, real world, stranger and grander than we imagined. And the universe still holds countless secrets and mysteries, is waiting for us to relentlessly reveal and explore.